In this video lesson, we're going to learn to determine slope of a line from a table, a graph, an equation. So I've just kind of given you an example of a table here. We have two different graphs over here, or a graph of a line. And then you can also see equations that go with the graph. So again, we're going to be able to determine slope of a line just from looking at a table, a graph, or an equation. Now, just real quick, I want to talk a little bit about a review with fractions. A lot of times when we talk about slope, we're looking at fractions. So for instance, let's just do a couple quick examples. Let's say we have a fraction of 2/3 and we want to multiply it times 3. I just want to remind you that we could just write that as a fraction, 2/3 times 3 as a fraction as well. And when we multiply fractions, we just multiply straight across. The numerators times the numerator and the denominator times the denominator. So in this example, we have 2 times 3, which is 6, and 3 times 1, which is 3. So again, 2 times 3 is 6, 3 times 1 is 3. And then of course, you have an improper fraction of 6 over 3, which is 6 divided by 3, and that equals 2. All right. Now, let's take a look at, let's do just another one real quick. Let's say we have, example 2, let's just say we have 3/4 times 4. Or maybe we could say times -4. Let's just show that like this, 3/4 times -4. Again, we can write that as two fractions, so 3/4 times -4 over 1. And we multiply our numerator straight across and our denominator. So we're going to end up with 3 times -4 is -12. And 4 times 1 is 4. And -12 divided by 4 equals -3. So again, just a quick review of multiplying fractions. All right, now take a look at slope. This is kind of an activity we're gonna kind of work through together, but in this video, we'll just kind of be working it out. But let's see. This says to use the function y equals 3/4 x minus 5 to complete the table. Okay, so this is a function. And the way we're going to complete this table is to evaluate this function using these x values. Now, you've learned how to do this. We take the x value, we plug it into x, and then we work out the function to determine the output. All right, so let me go over here to the next page, and let's take a look. So notice I've rewritten the function, or the equation, y equals 3/4 times x. So we're going to plug in an input, and we're going to work it out to get the output. We're going to do that 3 times because on our table here, we show a -4, a 0, and a 3. Okay, so let's start with the -4. I'm just going to come over here, and I'm going to plug it in. Okay, so now we have y equals 3/4 times -4 minus 5. And when we continue working that out, it's going to say y equals -3 minus 5. When you work out 3/4 times -4, you end up with -3. And then here, -3 minus 5 equals -8. So our output is -8. So when we input at -4, the output is -8. Okay, now let's try the 0. So when we plug in a 0 and we work it out, well, you probably understand that any fraction, or 3/4 times a 0, anything times 0 is 0, okay? So then our function, our equation would look like this. Y equals 0 minus 5. And 0 minus 5 equals -5. So again, when you input a 0, the output is -5. All right, and then the last one, we're going to input a 4, and we're going to put it inside the parentheses here. Be sure if you're using a calculator that anytime you input a number into the function that you put the input value that inside parentheses, okay? But if we do 3/4 times 4, we're going to end up with 3. So now our function or our equation is going to say y equals 3 minus 5. And 3 minus 5 is -2. So when we input a 4, the output is -2. Okay. So now we have a table of values here that you can see. So when when x is -4, the y is -8. When x is 0, y is -5. When x is 4, y is -2, okay? Well, these are now points or ordered pairs that we can plot on a graph. Again, by ordered pair, I mean we have a -4 and a -8. All right? Or we have a 0 and a -5, and finally a -2. Nope, that's not right. And a 4. When we input a 4, we get an output of a -2, okay? All right, so let's move on. Here we have some instructions, and it wants us to, we're gonna plot the 3 points on the graph and connect with a continuous line. By that, I mean arrows on both ends, okay? So let's use our table. Remember when we plugged in a -4, we got a -8. When we plugged in a 0, we got a -5. And when we plugged in a 4, we got a -2, okay? So let's start with -4, -8. To plot that, the x is -4, the y is -8. So we start here at 0, 0. The x is -4, and the y is -8. So we would go down to -8, and this would be our point. So let's go ahead and start with a point there at -4, -8 would be right here, okay? Then we have another point at 0, -5. Well, 0 as an input value means we don't go right or left, okay? We just stay on the y-axis, but we go down to -5 on this one. We input a 0, we got a -5. All right, so I'm gonna put a point at 0, -5, okay? And then finally on our table here, we have a 4. When we input the 4, we got the -2. So to graph that, we start at 0, 0, always the origin, and the x value is 4. The x means we go over +4, positives go to the right, and then the output was -2, so we go down 2, and that's where we put our final point at 4, -2. So I'll put another point there. And then we're going to connect these points with a continuous line. That means arrows on both ends. So that'll look something like this. All right, and then we could go ahead and draw some arrows on the end just to express that it continues to go through those points. All right. Now let's jump here. Let's return up here. I'm sorry. It says using your graph, determine the rise, determine the run, and then put them together as rise over run. So what that means is looking at these points. All right. What is the rise to go from one point to the next point? So notice this one here is at -8, and it goes up to -5. Well, that is a rise of 3 units. I could draw it out like this. I have to go up 3 units to get to this one, okay? So we could say it's a rise of 3. Then I have to run to get from this point to the other point, okay? We have to go over 1, 2, 3, 4 units. Notice we're at -4 and we go over to 0, or we're at 0 and we go over to +4. What we're doing is we're going over 4 units each time, okay? We're going over 4 units each time, so we have a run of 4. Again, we call that a rise of 3 and a run of 4, all right? Now let's go ahead and put these together with the rise as a fraction, with the rise on top and the run on the bottom, okay? The rise was 3 and the run was 4. 3 over 4, okay? Now it says to look back at your equation and your table. Where else can you find your slope of rise over run? Now let me remind you that the function was y equals 3/4 x minus 5, okay? Well, if we look at our equation, look back at your equation, where else can you find your slope? Well, our slope is this rise over run, up 3 over 4, up 3 over 4. Well, notice in the equation, there is a 3 over 4 right next to the x. It's being multiplied by x, okay? Technically, the coefficient with the x is 3/4. This is our slope, okay? Now, if you look at the table, where else can you find the slope? Well, you will notice that when we go from -8 to -5, we are adding 3. And we go from -5 to -2, we are adding 3. It's a change of +3 every time with the y. Now, if you come over here to the x, okay, to go from -4 to 0, we add 4. And to go from 0 to +4, we add 4. All right. So again, you can see the 4. So you have a change of 3 and a change of 4. So the change in y is 3. That's the rise. And the change with the x is the run. So the slope, which we're learning to find, the slope is actually what we call the change in y over the change in x. And that is how you identify a slope using a table, using a graph, or looking at the equation.